Hi guys, so we're going to go over solving quadratic equations. Just note before you start solving a quadratic equation, make sure that one side of the equal sign equals to 0. So if you're ever wondering which side of the equal sign should be 0, a should always be positive. So you're going to move everything to one side of the equal sign, making sure that a, which is the coefficient of x squared, will be positive. There are a couple ways to solve quadratic equations, which include factoring, completing the square, and the quadratic formula. So today we're just going to go over the quadratic formula. So one of the things the quadratic formula includes is this expression inside of the radical, which is known as the discriminant. And the discriminant will always tell you how many solutions you can expect to see. So if you look at example 1, the number in front of x squared is the coefficient, which is known as a. It is positive because if there's nothing there, it's a positive 1. So that means I'm going to move everything to the left side of the equal sign before I start my problem. So to get rid of this minus 5x, I'm going to add it. And whatever I do to one side, I'll do to the other. So this leaves me with x squared minus 5x equals negative 4, and then I'm going to move this negative 4 by adding it to the other side as well. So this side of the equal sign, the right side, is now 0. There are no like terms, which is why I can't combine anything. This one has x squared, this one has x, and this one has nothing at all. So I bring them down from greatest exponent to smallest exponent. And from there, I can tell my coefficients a, b, and c, and what their values are. So a is the coefficient of x squared, which is nothing there, which means it's 1. B is the coefficient of x, which is negative 5, and c is that constant, which is 4. So once I have a, b, and c, I can find the discriminant as well as use the quadratic formula to solve. So since it asks for both, I'm going to start off with the discriminant first. So the discriminant is the expression inside of the square root, which is b squared minus 4ac. So b is the negative 5. Make sure it's in parentheses when you square it, especially with a calculator, minus 4 times a, which is 1, times c, which is 4. And then from here, remember your PEMDAS, exponents first. So negative 5 squared gives me 25, minus 4 times 1 times 4 gives me 16. And from there, 25 minus 16 would be 9. So if a discriminant is positive or greater than 0, so I'm just going to write it here, greater than 0, it will have two real solutions. So that means when we solve for x using the quadratic formula, we can expect to see two real answers. If the discriminant equals to 0, that means we will only get one real solution. And if the discriminant is less than 0, that means we should expect to see two imaginary answers. And we'll go over that as well. So for now, we have the discriminant. We know that when we solve for x, we should expect to see two real solutions. And from here, I'm going to use my quadratic formula to solve for x. So I'm going to write negative, and I'm going to replace the b with negative 5. So just worry about replacing all of the letters with numbers first, and then we'll solve from there. Plus, now this is the nice thing about finding the discriminant first. B squared minus 4ac has already been solved. It was 9. And then all over 2 times a, which is 2 times 1. So starting off here, we have negative 5, which would give me positive 5. Plus or minus, the square root of 9 is 3, all over 2 times 1, which is 2. So in the discriminant, we've already determined there's going to be two real solutions. So from here, the two solutions are going to be 5 plus 3. Make sure you solve that first and then divide by 2. And 5 minus 3 and divide by 2. So 5 plus 3 gives me 8. 8 over 2 would be 4. So there's one solution of x. And the other solution, 5 minus 3 is 2. 2 over 2 is 1. So there's the other. One side of the equal sign is already 0, and a is already positive. So I'm going to write what each letter represents. So a is 2, b is 5, and c is 7. And from here, I'm going to determine the discriminant first, which would be b squared minus 4ac. So I would take 5 squared minus 4 times a, which is 2, times c, which is 7. And I'm going to get 25 minus 56. So from here, I'm going to get negative 31. So since this is negative, remember the rules of the discriminant. If it's less than 0, that means you should expect to see two imaginary numbers or solutions. So from here, I'm going to use the quadratic formula to solve. So it would be negative b. B would be 5. Plus or minus the square root of, and we've already solved for b squared minus 4ac, it's negative 31, all over 2 times a, which is 2 times 2. And x equals negative 5 plus or minus. Now there is no square root of 31, but initially we need to take that negative out. So the way to take a negative out of a square root is make it imaginary, square root of 31. So one thing to note is that I is equal to the square root of negative 1. And for future reference, I squared, if I were to square both sides, I squared equals negative 1. So the way to take a negative out of a square root is to write I, and then you're left with positive square root of 31 all over 4. So I can't add a real and an imaginary number together because they're not like terms at all. So that means that my two answers are negative 5 plus I square root of 31 all over 4, and the second answer is negative 5 minus I square root of 31 all over 4. So these are my two answers. And that's it. I hope this helps.